Now we're going to take a look at equations that are set up in the form of proportions. And I'm sure you guys have worked with proportions before, and we're going to start with some of those basic proportions, but by the end of this lesson we're going to be looking at some that are a bit more complex, but that are still solved using the same method. So remember that a proportion is a statement of equality between two equal ratios, and this equal sign is what is going to let us solve a proportion. Remember that we have our means and extremes property of the proportion, or basically cross-multiplying, which says that if I multiply one numerator by the other denominator, and I do that twice, I'll get the same product both times. So here we have 20 and we have 20. This means that these fractions or these ratios are equivalent. It also means that if we have an unknown in there, we can cross-multiply to find the unknown. So if I look at each of these ratios, we want to figure out whether they're proportions. So if we do 4 times 33, that's going to give us 132. And if we do 12 times 11, that's also going to give us 132. So we know that this is a proportion. If we check the next one, we're going to do 8 times 17, which is 115. And then if we do 9 times 16, we can check and see, and that's going to give us 144, which means that these do not form a proportion, so those are not equivalent. For the last one, we're going to multiply 2.1 times 0.7, and we're going to get 1.47. And then we're going to do 3.5 times 0.5, and we'll get 1.75. So those are not equivalent ratios. But we're not really going to be checking whether ratios are equivalent. We're going to be having a proportion that has an unknown quantity in it, and we're going to have to find that unknown quantity. So here's a very basic proportion. We start by cross-multiplying. So we have 5x, and then we have 6 times 15, so we have 90. This is the first step that you always want to show. You always want to start with that equation that you get for multiplying. You need to have this in order for your work to be complete, because otherwise we don't know where that equation is coming from. Then we divide both sides by 5, and we will get x equals 18. Alright, so that's our basic equation. If we look at this one, it's a little more complicated because we have this binomial down in the denominator. So I'm going to multiply 4 by the whole quantity k minus 5. And then we're also going to multiply 3 times 8. Now I have to use my distributive property to simplify the left-hand side. So we're going to have 4k minus 60 equals 24. And then we would just go through and solve. So we can add 60 to both sides, divide by 4, and we're going to get the k equals 21. And we'll put that in roster form. For right now, unless we explicitly ask, you won't have to do a check step for these, just because the checks can get a little dicey. Okay, go ahead and pause the video and try this first proportion on the left-hand side. Alright, so depending on where you wrote your terms, your equation may look a little different. You may have chosen to move your variables to the right-hand side instead of the left. That's okay. Either way, you should still get a solution of negative 21. Go ahead and pause and try the second one. We cross-multiply. We have 5 times n minus 12, which is 5n minus 60. And then 2 times n minus 6, which is 2n minus 12. Go through and solve, we get 16. Make sure that you're not combining steps. So example, from here to here, the only thing that we did was move the variable term. We didn't also move the constant. So for right now, we should still only be doing one step at a time. You want to make sure you're not skipping any steps in your work. Okay, now when we have this negative sign out in front, we have to decide where it goes. I usually always put it in the numerator, just because it's a habit that I have. But you can only put it in the numerator or the denominator. So you have to pick one, because otherwise, if you move it into both, then it's negative 1 over negative 1, and it cancels out to positive 1, which gets rid of the negative altogether, and we don't want to do that. So once we've got that negative up with the 6, we can go ahead and set up our cross multiplication again. And we're going to use that distributive property, except this time we're going to distribute negative 6 through to the 7p plus 2, and we'll have positive 10 to the 2p minus 3. So we'll get negative 42p minus 12 on the left, and 20p minus 30 on the right. I'm going to add 42p to both sides, so negative 12 equals 62p minus 30. Now I'm going to add 30 to both sides, So we're going to have 18 equals 62p. And then we'll just have 18 over 62, which we can reduce that to 9 over 31 for p. And we'll put that inside our brackets here. Go ahead and pause the video and try the last one here on your own. Alright, for this particular proportion, because we have that negative sign on both sides, I can write at the very beginning, divide or multiply both sides by -1, and that goes away. So now we just have two positive ratios. We cross multiply and we solve, and we get an answer of 13/5.